Okay, so today we're going to be talking about circles. So first of all, what is the definition of a circle? A circle is the set of all points equidistant from a given point called the center. So the distance from the center to the circle is always going to remain the same. And a radius is a segment whose endpoints are the center and a point that's on the circle. So since the circle is all the points that are equidistant, all the radii are going to be congruent to each other, right? And do you guys know anything about how a radius is compared to a diameter? It takes 2 radii to make a diameter, right? So the radius is half the diameter. All right. A chord is a segment, okay? It's not a line, it's a segment whose endpoints are both on the circle. So a chord touches a circle in 2 places, and it's a segment. And it's important that you understand the difference between a chord and later in a second we're going to talk about secant, which also goes through a circle twice, but it's a line. So make sure you remember the chord is the one that's a segment. All right, and then the diameter is just a special chord that contains the center. And so the diameter is 2 times the radius. Okay, so all that's in our figure there. Are we good? All right, so when we name a circle, I have to have a way to refer to a circle. We use the center point. So actually, I'm going to call this center point up here C. And so if I was naming that circle, I would call it circle C. So we use the center. And usually they'll draw a circle with a point like that to mean circle, and then the letter C. So that first circle that we drew, that was circle C if I call that center point C. Okay? Does that make sense? Okay. All right, so a secant is similar to a chord, but it is a line that intersects in 2 points. A chord is a segment, a secant's a line. And a tangent is also a line. It intersects in exactly 1 point. So this is different than the tangent of angles that we were dealing with in chapter 7. Now we're talking about a tangent to a circle. And it's a line that intersects once. And then the point of tangency is that point of intersection where the tangent and the circle touch each other. Okay. If I wanted to name this circle, they would have had to have given me a point. So say I call this one D, that would be circle D. And you would just write it circle D. Okay? All right. Okay, so now we're going to look at the figure and tell whether it's a line array or whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent. So if we look at A, it says BC, and it's a segment BC because it has just the line. So what do you guys think BC is? What do you think, Scotty?
Radius.
Does anybody agree with them? Yeah, it's a radius. Alrighty, maybe I'll draw sticks. Alright, now we're looking at line EA. So that's this line here. Becca Chadwick, you got any idea what that might be? Yes, it's a secant because it's a line, it's not a segment. Alrighty, then we have DE. right here. Clayton, what do you suppose DE is? Yep, that's a tangent. All right, next one they gave us was, I need to go further here. AB. So what's AB, Mackenzie? Yes, it is. And then finally, the last one we have is FA. And that's just going from F to A. It's a segment. So what do you guys think that is? A chord. It's the only one left, huh? Right, and because it's a segment, that's why it's a chord. It's not a secant. Okay, so you'll have some problems where you have to look at a graph and determine either radii or diameters for it. So on this one, they want me to know the radius of A. So literally you just go from the center, and you can either go straight up or straight down, or you could go horizontally. And because they gave you the point that was right on the intersection, you can tell that the radius of that is 2 by just counting how many squares. So what's the diameter going to be? 4, yeah. And then if I look at circle B, here's my center. When I go over, how far do I have to go this time? 4. And then what's the diameter? 8. Those are pretty easy. So, okay. All right, coplanar circles means they're in the same plane. So there's different ways that they can be related to each other. There might be 2 points of intersection, like the first figure. In the middle, we've got tangent circles that have just 1 point of intersection, so one can be inside the other, or they might be right next to each other. And then finally we have concentric circles, because those are circles that don't touch at all. Like if you look at this circle inside of here, it's concentric with this circle here. So the concentric ones are just the ones that are highlighted. These other ones just don't have any points of intersection. So what's important with concentric circles is they have the same center, but they have different radii. Okay. All right, and then we can have common tangents. Oops. There we go. And it can be a line, a ray, or a segment that's tangent to 2 coplanar circles. So if it goes between the 2 circles, then it's in common internal tangent. But if it stays on the outside of the circles, it's a common external tangent. So if we look at these figures here, we want to see how many common tangents the circle has. So if I look at A, off the top of your head, why don't you guys kind of just show me on your fingers how many tangents you think A is going to have? So I'm seeing 1 and 2. So let's see here. Got one here, right? And we've got one here, right? And we have one here. How many do we have? 3, yeah. All right, how about B? Show me what you think about B. Yeah, that one's going to just be 2. Can't go through the middle because there is no tangent point in the middle. If I went through the middle, they would be secants because I'd be crossing 2 points. Okay, and then the last one, what do you think? How many? Just 1, yeah. On the outside here, because they're tangent circles, that's the only place, so it only has 1. Okay. Okay, so if a line is tangent to the circle, then that line is perpendicular to the radius or the diameter. perpendicular to the radius. And the radius is just part of the diameter, so you could also say it's perpendicular to the diameter. And tangent segments that have a common external point. So right here I have these two tangent segments, and they have a common point right here at S, right? If that's the situation, then those two segments are congruent. Which they've marked them here. But yeah, RS is congruent to TS. And that's always going to be true if you have two tangents. These have to be tangents, though. So how we're going to end up using that is with Pythagorean theorem. So in the diagram, RS is a radius of circle R, and we want to know, is ST tangent to the circle? Well, first of all, let me make the picture a little bit clearer. The 16 is referring just to this distance here, okay? So how can I figure out what this other distance is from the circle to R? What do you guys think?
Well, TS is 24. So then you subtract 16.
No. Any other ideas? What kind of segment is this segment right here? What part of the circle? Is it a secant? Is it a chord? Is it, what is it? I heard it out there, what? It's a radius, right? And aren't all the radii the same? So what is that missing part? It has to be 10 also, doesn't it? Because it's a radius. So you find that the whole thing is 26. So now how would I figure out if it was a right triangle? I would use the what theorem? Pythagorean theorem, right? So if it's a right triangle, then I'll know that this is a right angle, which means it is a tangent. So let's see if that works. Does a squared plus b squared equal c squared? That's what I want to know. So 10 squared. Yes, it is. So yes, you can do it that way. Or as Zach noticed, it's a 5, 12, 13, because if you just divide them by 2, then it comes out. So if you do it the long way, you get 100 plus 576 equals 676. But yeah, it's a Pythagorean triple, so you could also look at it that way. But then you should have an explanation or something, so I know you're not just randomly guessing yes and no. Okay? Okay. And then I've got one for you guys to try on your own. You can just do it in your notes or on a whiteboard, I don't care. So RS is a radius, is ST tangent. And again, the 7 is referring just to this outside piece right here. So you can't base it just on what the picture looks like. You have to actually test it out and see if it works. Okay, what do you guys think? Thumbs up or thumbs down?
Is there supposed to be a number at the bottom, like where RT's at?
That's a 7. So how long is this whole distance here? 7 plus 12, right? Or 19. So you have to test 16 squared plus 12 squared and see whether or not that equals 19 squared. So did anybody figure that out?
Oh, no.
Very well. In the interest of time, let's finish it off. So this one is a no. Okay. Okay. I need to show you this because this is going to go back to remembering how to square a binomial, which we did not too long ago, but you guys might not remember. So this time I don't know the radius, right? But I know that this, oh shoot, For this length, I'm going to use r plus 49. So that means for a squared plus b squared, I'm going to do r squared plus 77 squared. That has to equal r plus 49 squared. Now to square a binomial, it's not just going to be r squared plus 49 squared. 77 squared is 5929. And then what you had to remember is you have to do r plus 49 times r plus 49. So r times r is r squared, r times 49 is 49r, 49 times r is 49r, and 49 times 49 comes out to 2401. So if you subtract the r squared from both sides, you get lucky. This one you don't have to factor. And then we subtract the 2401. And you end up getting that 3528 is equal to 98r. And so when you divide, you get r is equal to 36. So you're going to have to remember how to square your binomials when you guys do your homework, okay? All right, you guys can go now. Okay, here's one more example. Now I've got two tangent segments, and they are both going to point Q. So I know that those two have to be congruent to each other. So to solve it, you would just set 3x plus 5 equal to 32. So if we subtract 5, we get 3x equals 27. And so x equals 9. And that concludes the video.